All right, I am going to go over basically what we did in class. I was really um, impressed, especially with my third period class. We started using the blue hands and started doing participation that way, and I really liked it. I think from now on during class, we're going to start raising the blue hands, and so that way I can call on people. I feel like sometimes I call on people and it takes a really long time for them to answer, or they get really uncomfortable, or they don't know the answer, and then everyone feels awkward. With that class, it worked really well. I wish that we could have met and gone through that same process. It was pretty cool. It was a good class. I enjoyed it a lot. So what we did was we zoomed for 30 minutes and then I let them know. And so this is basically your task for tomorrow. You need to, obviously you're watching this video because you're not coming to class. So you're going to go through the same process they did with the Zoom call, basically is what you're watching right now. And then on your own, due Monday at 11:59 p.m., you're going to pick between the Cricut Lab and the Pillbug Lab. You're going to watch the chi-square video. It's only 11 minutes. And just jot down some notes. You don't have to copy down every single thing that he says, but jot down some notes. And you answer some ed puzzle questions along the way just to kind of, so I can see, okay, how well are they receiving this, so I'll know exactly what to do on Tuesday in class. And then we're going to do an M&M lab in class on Tuesday. My goal for Tuesday is just to do some practice chi-square problems in the M&M lab during the 90-minute block and then not give you any work outside of class. I know juggling all of this week has been pretty difficult, but I think I'm going to try to figure out a better way to make it so that you're doing 90 minutes worth of work each time we meet, and I'm going to do my best. I can't promise every time just because of how much time's getting shaved off of this class because of your off period that I'm giving you. That's 90 minutes every week that's getting shaved off of my class that I used to have. But I'm doing my best to make it so I'm giving you 90 minutes of work 3 times a week, and then your only homework is like to study for stuff. So let's see next week. I think at the end of next week with all of your classes, you're going to feel a little bit better. I know it's a lot of platforms. I know it's a lot of technology, but the first week of school is always uncomfortable, and it's always uncomfortable knowing where are you going to go, what are your teacher's expectations, blah, blah, blah. So that's kind of the spiel I gave them in class. Nope, too far. So for your scientific method notes, so remember you watched a video over the scientific method in chapter 1 notes, and it was a lot of information jam-packed into 26 minutes. And I had a lot of questions about, wait, do you want us to know the 5 themes? Do you want us to know about DNA? Do you want us to know about evolution? And the answer is no. I don't need you to know anything about those 5 themes except to just have in the back of your mind, okay, this is the direction that the class is going. And then I also need you to have in the back of your mind that the main overarching theme, which is dictated by College Board, is evolution for this class. So if you are part of a religious organization or anything like that, it's fine. You don't have to believe in evolution, but just so you know, I have had students in the past that due to religious reasons really struggled with that content. And so it's just something to think about moving forward. Obviously, I'm not saying if you don't believe in evolution, you have to drop the class. Of course not. But just so you know, if you don't believe it and you're part of a faith that's very opposed to the idea of evolution, that is going to be kind of a struggle. So just to know that. All right. The other thing, so you don't need to know the 5 themes. I just wanted you to have in the back of your mind what this class is going to be about. What I really need you to know for the assessments, the quiz next week, and for the test that's going to happen right before you go on Labor Day break, I need you to know how to pick out these things right here. If I give you an experiment design or I give you a data table, can you tell me what the independent variable, dependent variable, constant, control, null hypothesis, and alternative hypothesis is? Because I literally will on your quiz, I'm going to give you a data table and say, what's the null hypothesis? Or what's the dependent variable? And some of those questions will be fill in the blank questions, not all multiple choice. So what we did is we went through several data tables and I just called on random people who felt confident that they had the right answer. And it went pretty well, at least in third period, it went pretty well. Things were a little rocky in the other class. I think it was just the way I was calling on them. But if we look at this chart right here, the title says breathing rate of freshwater sunfish. And you'll see on the left side, temperature is in Celsius and it's increasing as you go down. Temperature is increasing. And then over here you see breathing rate per minute. Breathing rate Cool, it goes up. Ooh, interesting, then it goes down. Okay, so if you looked at this, you have to ask yourself, what's the independent variable and what's the dependent variable? Well, the independent variable is the thing that the scientist is manipulating. Is the scientist really controlling the breathing rate? Like, do they know exactly what, are they setting the breathing rate? No, they're setting the temperature though. So the temperature is the independent variable. The dependent variable is what the scientist is measuring, and that's breathing rate. All right. The null hypothesis would be there is no significant difference, or there is no significant effect that temperature change has on the breathing rate of the fish. There's no significant effect that temperature has on the breathing rate of the fish. That's the null hypothesis. The null hypothesis is like, it's basically like saying like, this whole thing is useless. There's just really no correlation. There's no correlation in increasing temperature and increasing breathing rate, okay? The alternative hypothesis is just gonna be the opposite. There is a significant effect that temperature has on breathing rate. And then if you look at this data table, you're like, well, why are we even saying those things? Obviously, raising the temperature has an effect on breathing rate. You can't do that in this class. You can't say increasing temperature significantly affects breathing rate. You're not allowed to say that in this class because, and I'm going to go through on Monday some examples where you're going to be like, oh, okay, I get why now. And you'll see, you can't say that without doing any statistics behind it. You just can't. You can look at this chart and say, yes, there appears to be a correlation, but you can't absolutely say, I reject the null hypothesis. There's definitely a significant effect that temperature has on breathing rate, all right? The control, what would the control be? This is what a lot of people struggled with the lecture. The control would be the basis of comparison, and that would be the temperature at which sunfish normally live. That would be your control. And then your constants are going to be the variables that you don't want to change because you don't want them having an effect on your outcome. You want the outcome of breathing rate to only be attributed to the change in temperature, nothing else. So what are some things that you'd want to keep constant when you're doing this experiment? Well, you'd want the water quality to be the same, right? If there's certain minerals or solutes in the water of the fish at 10 degrees Celsius, you better make sure that the one at 18 degrees Celsius has the exact same water. Otherwise, the difference in breathing rate could not be attributed to just temperature. It could have something to do with the water quality. The other thing would be the size of the sunfish. You want those to be about the same. The age of the sunfish, you want those to be about the same, because it is true that the size and the age of an organism can actually affect the breathing rate. So we want that to be the same among all these groups so that the difference that you see can only be attributed to this independent variable. Okay, then we did another one. So this is, if you want to pause and maybe write those down, if you want to, you don't have to. This was just practice. But if you got it, and then I'm going to move on. All right, then we looked at this one right here. And we went around the Zoom room. So you see a plant, phosphorus sufficient plant, phosphorus starved plant. What's the independent variable? Well, it looks like the scientist is controlling phosphorus amount. So that's your independent variable. What do you think the dependent variable would be? I don't give you a lot of information on this one, but you can pretty much guess. Well, it looks like they're trying to measure the health or the growth or the height of the plant as a result of phosphorus levels, okay? So independent variable is phosphorus, dependent variable is the size of the plant. The null hypothesis would be phosphorus amounts have no significant effect on plant growth, okay? That would be your null hypothesis. There's no significant difference between what we expect and what we observe. And what we expect is that they're all just going to grow like this no matter what the phosphorus level is. That's what we're supposed to expect. The alternative hypothesis would be there is a significant difference between these two groups. Phosphorus amount does significantly affect the size, the health, in the height of plant growth. Okay? So basically with your null, you're saying my independent variable has no effect on the dependent variable. There's no significant effect. And with your alternative hypothesis, you're saying my independent variable does have a significant effect on the dependent variable. My laptop's going to die. All right, the control here, what would the control be? It would be what the usual phosphorus levels are for a plant. So I'd be willing to bet that this right here is actually the control. The phosphorus sufficient is the control, and then the experimental or treatment group would be the phosphorus starved group. Right? And what would your constants be? Well, what would you want to remain constant between these two? You would want the same amount of soil, the same type of soil, all other minerals and vitamins or in whatever nitrogen levels are all the same between both of them. You definitely want it to be the same type of plant, and then one student said something really good. They said, well, you want the starting size of both of your plants to be about the same. That way you can really tell a difference. And then the last things that students said was the amount of water that you give each plant. You want those the same between the two. The amount of sunlight needs to be the same, and the amount of carbon dioxide needs to be the same. All right, so these are all the answers that I just gave. If you want to pause the video and look over them, you can. All right, and then I gave this last one right here. I was like, all right, let's do one more. The effect of sugar solution on the heights of plants. All right, effect of sugar on height. Just from the title, you don't even need to look at the chart. Just from the title, you can say, all right, independent variable is sugar solution. Dependent variable is height of the plant. Null hypothesis would be sugar solution has no significant effect on height of plant. Alternative hypothesis would be sugar solution does have a significant effect on the height of plants. Okay, and then your control would, and we kind of went kind of back and forth on this. Well, the control would be what is the typical percent sugar solution in a normal plant out in nature? Well, Mother Nature doesn't cause sugar rain. That would actually be really inconvenient to have sugar rain, because then your car would be all sticky, and that would suck. But Mother Nature just rain without sugar in it. So our A group would be our control group. That would pretty much be our basis of comparison. And then constants would be the same as the one before. Same type of plant, same soil, same amount of water, same amount of sunlight. Sorry, my kids are screaming. They're just playing. Same amount of carbon dioxide, all of that kind of stuff, to make sure that your difference in height can only be a result of sugar solution and nothing else. All right, and there is the stuff for that. Okay. On Monday, because I'm totally obsessed with the COVID vaccine trial, the Moderna COVID vaccine trial going on right now, I am going to wait, and when I see you, not Monday, when I see you on Tuesday, this is the first thing we're going to look at is, and so start thinking about this. COVID vaccine trial. So Moderna and a bunch of other companies are doing a COVID vaccine trial. They want to see, does the COVID vaccine work? What is, and I'm going to ask you this when I see you next, what is the independent variable? What's the dependent variable? What would the null hypothesis be? What would the alternative hypothesis be? What is the control group? What would a good control group be for a vaccine trial? You know, with animals, it's easy, but when you get humans and intelligence and everything, what would a good control group for a vaccine trial be? And any other basic designs that you can think of. And then I'm going to run through a little bit about how vaccines work real quick and what is so super cool about this technology that they use to create this vaccine. So that'll be like 5-6 minutes when we meet on Tuesday. Okay, this is all I have for you. Once again, y'all's is not due Sunday. Yours is due on Tuesday.